Well, I cannot tell you how much I look forward to this event. There are people in this room, for those of you who are students, who have been similarly inspirational to me. Of course, and then Cleek, when I started my doctoral program as a person who came back to school to get one course to catch up and became electrified and plugged into a light socket by research, I had this teacher, and she was younger than I was, for goodness sakes, but she was so exciting, and that was Dr. Cleek. And so that was the first place I got really electrified. And of course, there is Dr. Toby, who has taught me how to be a gracious and hospitable person, and immune happiness for life, at the same time being seminal in her field and really mentoring me about some of the issues in hearing impairment that I didn't think about. And then my beloved Tom and Chris, who I got so excited when they got here, guys, to have this kind of people in the state of Texas. So I have really been looking forward to coming because it feels like a hotbed of people who are thoughtful, and I hope you appreciate what you have in your faculty. And there's my Anglia, in case you guys don't know. I was able to contribute something, I hope, to her education. And so it excites me to see her in this place. So here I am much later. As you heard, I was a speech pathologist before I went back for my doctoral work and did a lot of different kinds of things in rural and urban settings. And it taught me why I teach what I teach to people, so I try not to waste students' time. I try to be aware of how important it is to do theory to practice translation. And so where I ended up in my research life was in normal processes. And so that's what we're going to talk about today, and that is I'm interested in understanding how human infants develop one of the most complex systems that is available to the body and the capacities that humans have, as well as more complex than other systems in other communication systems in other non-humans. So I've been thinking about that for a long time. It's a great gig. I get to go look at and talk to people in other countries to think about their languages and so forth, so I can't complain. I was telling Emily I went to New Zealand most recently, and I figured I didn't know anybody there. I'd just see what color my hair was. I haven't seen it in 20 years or so. Look at this, you know what? Anyway, thank you very much for having me. And what I want to do is spend a little bit of time. I thought I would spend a little bit of time, since I do have a long research program, giving you a smorgasbord or a sampler, if you will, of some of the studies I'm doing and thinking about right now as they reflect my larger question that I've been addressing in my research life across this 25 years or so. Anyway, here we are. If I can get this going. I want to start with one of my heroes, Fentress, who studied motor behavior and organization of behavior and motor systems, and Dr. Fentress studied mouse grooming, and he made a hypothesis that complex behaviors in grooming emerge or differentiate out of larger undifferentiated movements. So that is something that has been really influential in my thinking about development of motor systems as they emerge within the language system. But I like his idea here, complementary frameworks can yield complementary insights. And so in the area of development of complexity with reference to motor systems, I think we have a lot of different insights. And so what I wanted to spend time today with you is to talk about how the program that I've been a part of at UT has developed an insight based on a paradigm of observational looking at very young children in the context of other paradigms for this, which now, interestingly and excitingly for me, include modeling paradigms. There are kinematic paradigms, acoustics, so on and so forth. I won't bother you with that, but I did want to explore basically the strengths and limitations of this observational methodology that I've been pursuing, where myself early on with Dr. Peter McNeilage in the psychology department, who I like to say was never a mentor but always an inspiration in my life, and we talked about how could you understand emergence of sequential output properties in early speech acquisition. So infants or adults. Humans do not say t or they put these precise sound qualities together in sequences to make infinite messages. And so we were interested in this idea of sequential properties just as a historical issue. My dissertation was a study of a single child from 14 to 20 months, and at that point people looked at, corpora of 10 or 20 or utterances of one child because they reflected the rules of the system. It seemed to me like, and they looked at consonants, so it seemed like it was phonological sexism to not deal with vowels at all. This is just me, that was how I thought about it. And my husband wrote a program for me, so I had over 100,000 tokens of this child to analyze to look for patterns. So it was an early example, unbeknownst to me, of databasing, which big data is big right now. I think that's important. And it comes up in a lot of fields, which excites me a whole lot, I must admit to you guys. All right, so I want to talk about some studies that we've been doing and talk about what their strengths and limitations are. So first of all, I want to acquaint you with our database. This is a database at UT. It's a longitudinal spontaneous speech corpora. We have 21 children, many hundreds of thousands of utterances, just monolingual English speakers with Texas accents for the most part. We collected monthly in-home between 7 and 36 months of age. So there are these 21 children, and so it's a very large corpora that's longitudinal for each child. We did hearing and cognitive development, vocabulary development with most of these children, so we had a good variety of background information to find out that they were developing pivotally. And we did an hour-free play with each child in the primary caregiver and research assistant. Toys and routines that occurred during that hour were the child's vocalizations and motor vocalizations were captured with wireless microphones that were on the child with the microphone distance maximally optimal. We did phonetic transcription. This particular data right now, which we had in our lab, is available on PhoneBank. I don't know how aware of PhoneBank many of you are, but it is a public open source database for phonological data. So there's an enormous amount of data in English across a wide variety of languages that's available. And they have just recently, in the video and audio, when it's available there, they just recently added Pratt. So all of the TSB database is now available as open source data on PhoneBank. We did all perceptually speech-like child vocalization, so we didn't transcribe other non-rhythmic syllabic vocalizations. So this is the onset of speech-like behavior. Right now, in my lab, we're working on the parent input for this large database with about 10 or 12 of the children, so that my colleague in France has Turkish, Arabic, and Berber, and Romanian, and Dutch, and French, and she's doing a parent input project, so we're kind of excited to get this English database put together so that we can look across languages to think about the parent input issue. So that's available to those of you who are interested in thinking about phonological patterning. So what were we doing this for? At the sort of, I like to say my students, the t-shirt message, if you have to put what you think on a t-shirt, what could you do? It's really hard to do that sometimes. Do try it yourself for various other issues. At any rate, Peter and I wanted to test movement-based phonetic perspectives on early phonological acquisition. That was our goal. And we were starting with individuals who were 7 months old. So that was the basis of our observational methodology choice. And I, just to sort of move the frame out a little bit larger, this really, this program overall stands within what I like to call a biological functional approach to phonological acquisition. And what it suggests is that when we're talking about this area of acquisition of complexity in language, we're talking about two things, about behavioral patterns and underlying knowledge. So if you are a syntactician or a morphosyntax specialist, you can think about knowledge with the phonological area, it necessitates understanding both behavioral patterning and underlying knowledge. So by definition, that makes it unique. I managed to spend 8 years writing that book with Lisa Medor, and it basically says this in a whole lot more words than that. So basically, the idea of knowledge patterns is a child in the acquisition phases is internalizing neurocognitive competencies rooted in manipulations in the real world. And these behavioral patterns could be seen as functionally adaptive patterns that respond to local context in the phonological sense. That might be the word level context or the utterance level context as the child becomes more adept at language. You're talking about the complexity of listen and talk and the length of utterances and so forth. But these behavioral patterns respond to local context and exploit, importantly, the dynamics of the perception and production systems. Very importantly, it's in terms of a biological functional approach. So the end result idea is that phonological outcomes result from multiple interactions between heterogeneous aspects of a complex system. Just to set you in terms of what might be the alternative hypothesis, the phonological paradigm suggests that children have phonological competencies available at birth that are triggered by maturation through perceptual input, and they are abstract knowledge properties. And behavioral output, especially the production system, is not included in these theoretical perspectives, nor, importantly, is function. So a behavioral functional approach suggests that there is pressure from the social environment to achieve competent listen and talk for the child. So that is the part of the heterogeneous system that we're talking about. So I'm going to talk about production this morning just a little bit. So some of you may be aware that Peter and I have tested this front content hypothesis. We're coming down a little further here, and our job or our goal for ourselves was to generate comprehensive explanatory phonetic perspectives, to push the production system idea as far as we could, see where we could get. Vocal patterns in acquisition. So what do modern human infants show with reference to behavioral patterns? And with viewing that, as I said, as the most complex action system and knowledge system available in nature. And also patterns in modern languages. To what extent do these patterns we see in children reflect immature systems that develop and adults are very different, or is there some retention of these basic patterns from the production system in service of efficient message transmission that are retained in adult speakers as well? So that was our big question. What about acquisition, and what about adult-child comparisons with reference to these patterns that we've been observing? So focus of the front content hypothesis is serial ordering tendencies in operational vocal system within and across syllable patterns. Does that make sense to everybody? I don't want to go too fast. The principle was that rhythmic mandibular oscillation accompanied by phonation is the capacity available to a typically developing human infant at the onset of speech-like behavior at between 7 and 8 months. Reliably, Kim Aller and his colleagues showed many years ago that it is very reliably available in human infants as a capacity, even in instances of very low socioeconomic status and other diverse issues. In my cross-language studies suggest and support very strongly that this emerges reliably in children across a variety of languages. My latest gig, which I loved, guys, was I got to be on a dissertation committee for a young man in Mali who studied Bambara and Fulfulde. And he started at 7 months and went to about 24 months. And so that was very exciting to me because it challenges our ideas about what is easy and simple. I'll tell you a quick little anecdote. it turns out that fulfillity has implosives. Implosives are sucking air in rather than using the respiratory system out. So those are hard, right? They shouldn't show up. They're not in very many languages. They're low frequency. Well, 7 of 7 infants showed presence of implosives in babbling in that environment. So that's why I like these studies that challenge us on what's easy and what's hard and what is the role of the perception system, which we did not, the frame content hypothesis does not incorporate. That's how I got to lead with Emily, is to think about hearing impaired children. So these mandibular oscillations are a capacity that is available to human infants for approximation of the serial organization of speech by the onset of babbling. As a clinician, I consider this enormously seminal. I don't have evidence-based practice level of information, but as a clinician, I've never one time ever seen a child develop oral language who did not produce rhythmic syllables. So it's been a very interesting, I haven't looked at that as a researcher, but I think it's an interesting kind of question to ask. So that is our focus in the frame content studies. So what I want to do today is spend time on 3 studies that are in preparation at this point, so they've been done and we're working on them. We just sent off the Kim and Davis yesterday, so it gets to be submitted. And consonant assimilation, variegated consonant sequences, and those are really related to serial properties and regularities. The last one, the lexical-phonological interface in early words, is to try to look, as we get into words, what's going on? What are the driving underlying forces for how words and sounds go together at the very onset of output systems for language. So relative to the assimilation patterns, what is assimilation? One consonant changes to become like another consonant. This has been studied fairly broadly from phonological paradigms. All of the hypotheses are based on, for example, underspecification or nonlinear phonology. These hypotheses are based on putative abstract representations and how they may drive the patterns that you see. So the focus or driving idea for this study was, could we look at patterns and try to make some movement-based alternative hypothesis for what we see. We had several other predictions. I'm just going to talk about a couple of them right now. Basically, our movement-oriented prediction was that there are going to be preference for forms that are available to the production system in accounting for patterns of assimilation. That would generally suggest that if you have bag, you would have more babs than you would have gags, because young children are known to produce quite a bit more labials, and often dorsals are much later in acquisition. The prediction 2 relates to the frame content hypothesis that the contiguous vowel within a system may have important influences on the kind of consonant sequences that you observe. So here's what it looks like, and this is where I want you to kind of be aware of my using spontaneous data and large databases and what it does and does not give to you. It's not an experimental paradigm. It is, however, longitudinal. So we used 10 children from our TSP database across 12 to 36 months of age. There were 1,467 assimilated word forms in the corpus of 20,000. So this is one place where we get big data and we get to look at patterns in this big database. There were 1,058 CVC and 409 CVCVs. Interestingly, assimilation has been of great interest to phonologists for a number of years, but there was never a count of the relative frequency of assimilation in some sort of large and representative corpora. So we found that assimilated forms accounted for only 7% of the entire corpus, not very high. Would you be able to guess what the highest frequency pattern was? Anybody? Anybody have an idea? Not assimilation. Oh, yeah, what?
Substitution.
Final consonant. consonant deletion accounted for enormous amounts. We know that infants in English across languages have a preference for open syllables. So the much larger pattern was final consonant deletion. This was kind of surprising to us based on the importance that's placed on it in the studies so far. So there were 17,000 CBC target forms and 2,000 CBC target forms. Not surprisingly, English is a monosyllable CBC-based language, largely in terms of demographics. So these children were moving that way very early. These are all normally developing children. So here's the place results. I'm just going to give you place results. So what happened was that labial assimilation was very highly more frequent than coronal or dorsal. What that means is if it was bat, it would be bad. The children were most likely to assimilate to the labial in a mixed place context. Coronal is next, and very, very few dorsal assimilations. This is in contrast with some of the proposals of phonological theory, and particularly a well-known study by Stelgammon and Stemberger a few years ago, made a very different approach based on under-specification theory. So we thought this was very interesting, and why might that be? Briefly, we characterize this as a movement-based hierarchy. Labials are the most available for children. They involve mandibular modulations only. We call that the basic frame in our research. Dorsals are the least available. They involve the back of the tongue. That is not as available for movement patterns in children who are typically developing. These LCD frequencies in early words are different from the input language. The input language, that is English, has coronals as highest frequency of occurrence. So they are in contrast to the frequency of occurrence of the input. As you may all know, coronals are the most frequent place category languages across the 6,000 languages of the world. So coronals are big. Why might that be? Tongue tips are flexible. They give you lots of things you can do with them. But these infants are assimilating in those places where they simplify or change the word to patterning in ways that may likely, we have interpreted this as a movement-based driven. This has a lot to do with you guys who are clinicians, by the way. I use it a whole lot in my clinical planning for children that I see, and it hasn't been tested. All right, so what about the vowel context effects? The expected CV co-occurrences, guys, are coronals with front vowels. So the idea, if you have a tongue tip, you're going to, and don't move the tongue within the syllable, you're going to get a front vowel opening from a front consonant closure. Labials with central vowels, no need to use the tongue in the labial context, so you open and you get a central vowel with lack of independent movement between the consonant and vowel, and dorsals with back vowels. So the two lingual CV co-occurrences, that is coronal with front vowels and dorsals with back vowels, occurred at above chance levels. These evaluations use the chi-square analysis, and so above 1 is above chance. So not universally confirmed, but largely in the lingual cases where the tongue is involved in the closure phase. So we interpreted this as meaning that in the lingual case where you are doing some sort of lingual closure, the likelihood of there being a vowel that reflects lack of movement between the consonant and vowel appears to be above chance. Does that make sense? At the word level, I mentioned earlier, we did CVCs and CVCVs. In the CVC context, the vowel effects were weak. Only one of the hypotheses were confirmed. In the CVCV case, all three were confirmed. So when we divided the word types out into two different ones, we got a much stronger confirmation in the CVCV case. You will recall, however, that there were many fewer CVCVs in corpora overall than there were CVCs. So what might be happening if we say that these vowel context effects reflect lack of independence of the articulators during the transition from the consonant to the vowel, and based on rhythmic oscillations of the mandible. The lingual effects were confirmed more strongly than the labial effect. And so in the case where the tongue is engaged, there appears to be more likelihood that there will be lack of movement of the tongue between the consonant and vowel portions of the syllable. Why not labial vowel effects? The tongue is not required. And we thought that that perhaps enabled a greater movement freedom for the tongue between the consonant and vowel within syllables. What about those word level differences? Here's the way we have interpreted it so far. In the CVC case, you have one mandibular cycle, and then you have to add something at the end, and you don't get to open again. So that is a more complex context potentially than CVC, where you're doing the same thing over and over. We know, as you may be aware, in babbling, children produce long strings of output that are CVCD. When they get to the first word period, they tend to shorten to single syllables, or in multi-syllable languages like in Callier Spanish, they may produce a large number of CVCDs, matching perceptually their language. So we thought that perhaps we saw some different kind of requirements for serial action in CVCs versus CVCDs. And so let's see. Both predictions were largely confirmed with reference to the importance of movement-based propensities and capacities in a child for serial operation in word-based forms. We thought that the results generally support the frame content principles, that movement-based principles appear to be guiding assimilation related output patterns in this formative period of word-based output. I realize I've only given you one of the many things that we analyzed, but I wanted you to have a sort of sense of how we were asking the question and evaluating it. This is not a surprise to you guys, especially those of you who work in clinical settings, but children move from constrained movement types and movement sequences to ambient language levels of specific complexity. And we can't get away with, and I expect some of you to hassle me at the end, we can't get away with just production system. We have to incorporate understanding of how perceptual influences might be guiding some of these output patterns that we see. Okay, let's see. Well, there's the second one, it's up there. Another thing that we looked at was what we call variegated labial choral sequences. As you know, very few adult speakers speak in reduplicated word target type utterances. That is untypical in any language that we know about. So we began to look at how does variegation happen, and we looked at different types of sequences. We looked at labial choral sequence effects in an early study with 6 infants at first words, and then we looked at 10 languages. This was a place where we really got kind of excited about this infant language comparison because we found it in the infants, and then we looked at 10 widely diverse languages, and we found that these labial choral effects in sequences were highly present, especially with reference to the choral labial pair. So adults appeared to retain this type of output form in their word-based forms in adult speakers. So what we wanted to do was look at a much larger database. That was a small database, and consider individual differences, because again, this is something that's pretty important. You can see this big effect, but was it accounted for by one child or 2 children, and there were 12 children? So we wanted to look at individual differences on this. So again, using this database, we used 18 children from our TSB database. We actually did the analysis on childless using PLAN this time. But we started at the onset of word use and went to the onset of 2-word utterances. And this was between 9 and 21 months across these participants. We looked at CVCs only. We had 796 types in this corpus and 4,109 tokens. So it's a fairly large database. Here is our results. So what you see here is CVC, labial, cornal, and dorsal. This is place analysis, labial, cornal, and dorsal. What you'll notice is that the relevant comparison is labial cornal versus cornal labial. All right? So we had 28% of the overall group of 21 children showed, they showed 28% of these variegated sequences were labial cornal versus 4% cornal labial. Lots of difference in that relevant pair. Not very many labial sequences, a large number, 28%, almost the same of cornal sequences. So when children did reduplication, they did cornal. When they did variegation with reference to these two pairs, they did labial cornal. Huge. 70% of this corpora showed final cornals, even in the dorsal case. So that was very interesting to us. This is types, guys. We have different. So then we looked at tokens just for kicks. And we find labial cornal 30.2%, cornal labial 2.1%. Almost no cornal labials relative to labial cornals. Again, labial was 4.3% and cornal was 28.8%. So in both types and tokens, we see this enormous propensity to start with closing your lips and then engage the tongue, rather than start with the tongue engaged and then go to the lip closure. Very huge. So what about individual differences? Do we have two kids that did something different? If you want just the time we have available, you'll notice here are these large numbers here over on types and tokens, percentage-wise, and types and tokens for labial or cornal, which we saw a big group effect. There is no child among the 21 children who has an opposite kind of pattern. And they all have fairly low amounts of cornal labial. Here is a child, this is Rebecca, she was my dissertation participant, and she had lots of data. So her raw numbers are very large. And so you could, if she was different, you could say, ha, there's that kid with a lot of numbers, and she accounts for the difference. But we don't see any difference. This is a very robust effect. You will remember in the adult language data that it has been shown to be retained in adult speakers as an option. So what we have here is as speakers move toward variegation, at least for consonant place here, in the service of efficient and rapid message transmission of complex messages, there is a basic propensity that appears to be started in children at the onset of words and retained in adult speakers. I might add that it did not show up in our analysis of babbling. So it appears to be something of a perceptual effect, at least because it's not there in babbling, but it is although boys and girls in babbling are mainly producing open syllables, so it's a little hard to analyze this. So what we found then is labial cornal more than cornal labial, so lips then tongue, far more than tongue than lips. In huge proportional differences. 70% of the word types and tokens end with a cornal, regardless of whether a dorsal is involved. Labial is far less frequent than cornal. So cornal is language-like. It's a place where children can attach to what they're hearing more readily. Labial cornal is most frequent in every child in both types and tokens, using both raw numbers and percentages. Huge effect. So we propose that at the onset of motor output for early speech forms, labial lip closure is more accessible to the motor system. Cornal requires tongue positioning. So we get this enormous effect in the required movement. Remember, our goal is to think about complexity. The required movement to more complexity in service of getting stuff said. Let's talk about the electoral college, Tom, or let's talk about your soccer school, or whatever it is we have to talk about real fast, all right? Or I'm going to stand behind a tree and scream and talk to you about something. We have to talk and listen very fast. I'm using him as a victim, all right?
That's what I am.
All right, all I'm saying is we have to talk about complicated things. And you're going to say anything, and I have to say something back. I don't have to, but I, you know.
Yeah.
At any rate, lots of requirements for us to talk and listen rapidly using our perception and deduction systems. So this is a very robust effect. I think it would be very important and interesting to look at boys and girls with significant speech differences in acquisition. So the third thing, which I've managed to move even further up there, is this lexical-phonological interface. This is the one I'm working on. It's been really, really hard. People have thought about it for a long time. Schwartz and Leonard thought about it a long time ago in terms of selection and avoidance. The more recent people are Ben Munson and his group who have done some interesting work on trying to think about lexical-phonological interfaces, and they make a hypothesis that at age 4, by age 4, and that's the beginning point of their children's studies, children are using lexical issues to make word form choices. What I'm going to say is about what I want to say, not whether I can say with my mouth. But we don't know anything about children younger than that. So we were interested in the younger than that piece. And it's not an easy question to ask. So our question was, is there evidence of dominance or lexical or phonological factors in children's word choices at the onset of words use? And so that is 12 to 36 months in our new, you might be surprised, not surprised, that's what our database has for us. We compared, to do this, frequencies of phonemes in children's early types of spontaneous word targets. We call that SWT. That is the words they are attempting to say. What are the phonological characteristics of the words they're attempting to say? That's SWT. With the frequencies of those phoneme types in the children's spontaneous word types actually produced, that was SWA. So if the word was ball, it would have a, for example, labial vowel cornal, and the child says baw, or bought, or balk, or whatever. So we compared what they should be saying with what they actually should. And you're going to see now this is messy business. All right? So it's been a real struggle, and let me show you where we got to. Anyway, our participants were 6 English learning children, again, from our database, and it was on Fawn. And I'm just going to show you place and manner. So there was place and manner, labials, cornals, dorsals, manner, orals, and fricatives in word initial and word final positions in this database. And we compared SWT and SWA with vocabulary size using some Pearson correlation analyses. And you'll see why descriptive stuff is not going to get it in this messy landscape where we're trying to look at children's growth. Again, this is a longitudinal methodology, as you've noticed. Okay, here is Ben, one of the kids. What we found for 10 of those 10 dimensions, remember there were 3 place and 2 manner and initial and final, so that was 10 dimensions we looked at. There were no statistically significant differences between SWT and SWA using these Pearson's correlations related to vocabulary size. I would point out that this axis has vocabulary size, and this axis is the percentage. The green is cornals, the orange is labials, and the gray is dorsals. The solid lines are targets, and the dotted lines are child actual. So you can't absorb all this right now, but I think this might be available to you later, and you're welcome to stare at it. All right, but so here's place, initial and final, and manner, initial and final. We have fricatives versus oral stops in our manner analysis. What you can see is that there's enormous variability before 50 words. This goes with stuff we've known for years, that the output system doesn't seem very organized necessarily for speech output before 50 words. And lots of variability, and so that's why it's absolutely necessary for us to do some sort of quantitative or statistical analysis, and that's what we've been struggling with. But what this says is for Ben and for 4 of the other children, Kaylee, Charlotte, Hannah, and Nate, there were also no statistically significant differences. What that means is that SWTs and the SWAs were not different from one another. So they weren't doing something really different with the targets, trying, for example, to produce extremely complicated word targets, and the actual productions were very reduced, would be the sort of implication here. We took this as a phonological, support for a phonological approach to word choices. I am producing words that are within my capacity. There's not a statistically significant difference between what I'm trying to do and what I'm actually doing. All right, so this is Ben, Kaylee, Charlotte, Hannah, and Nate. That is 5 of the 6 kids. What's kind of important here is you see 200 at the bottom. These are children who have a fairly steady amount of word growth, but not huge. And here is Geo. Her name is Georgia Peach. I like this. There's her parents with creative whatever. She may not like it when she's in middle school. But anyway, Georgia had a huge vocabulary from the start. She was a very, very facile, fast-moving child, and she had statistically significant differences between SWT and SWA using these Pearson's correlations. So that means that there was a difference between the target's patterns for place here and manner and the words she was attempting to say. We took that as a potential confirmation of a lexical hypothesis. She was trying to say things and not exactly worrying, if you will, that's a bit of an overstatement, accommodating what her own production system could do. So again, this is a really difficult kind of question to ask, a really difficult kind of question to evaluate statistically. We're looking at changing our statistical modeling. The stats people have suggested that we start after 50 words because we're getting some effects from this enormous amount of variability, so we stay tuned. But this is where we are right now, trying to understand what is the relationship of phonological capacities to socially salient lexical items that children try to say. What is evident is this enormous amount of variability, which has been remarked upon many times by scholars in this area, but can we come up with any regularities with reference to this topic? So all 6 children showed high variability in the first 50 word levels, just completely random almost all over the map. 5 of the 6 children showed no significant differences between the SWT and SWA patterns for the majority of the dimensions analyzed. We took this related to phonological capacity issues because their targets are not different than what they can do most frequently. One child showed real significant differences, and she was a child who was very precocious both in her phonological and her lexical development relative to the rest of the children. So she was very different. So we, at the preliminary place we are now, we would say that individual difference data in this case really appears to challenge assumptions that would be made on the basis of word patterns. So as I say, this is the sort of forward cutting edge where we're struggling with how to do this analysis, how to ask this question with a large database. I think the large database drives us to understand how these patterns operate at functional output and gives us a big amount of data. It, however, creates this enormously messy landscape to deal with and analyze statistically. So remember, our goal was to test movement-based phonetic perspectives to understand the nature of early stages of phonological acquisition. Most systems of analysis and actually do not, theoretical systems do not incorporate the movement system. Perception is heavily emphasized, for example, in psychology learning, and perception-based learning is heavily emphasized in theoretical systems of language acquisition. In phonology, we have theoretical models from phonological or linguistics that suggest abstract properties are driving the output system. There is no incorporation at all of how the child might be producing issues. So what this little smorgasbord I've given you, which I realize is a little bit quick for some of your questions that you might have about these studies, and I'm glad to address those. But we feel like there is a real role for movement-based capacities in understanding the formative stages of language output and the quality of words and word types that children produce, how they produce them. Phonological outcomes, to our mind, result from multiple heterogeneous interactions between aspects of a complex system. So minimally, of course, production and perception, but the functional social consequences of trying to communicate using the system that you're just getting off the ground. So as I say, this is a quick tour, if you will, through, well, I'm going to say this, because I think I have a little bit of time left, because this is the newer theoretical foundations for this work. So we've had psychology and social cognition and a lot of ideas coming out of psychology, and we've had linguistics and a lot of ideas about knowledge. What are interesting and challenging kinds of theoretical approaches, for example, embodiment theory, which has been studied in particular in robotic contexts. Liama has said penetration between the organism and the environment creates the complex behavioral outcome as well as the eventual competence. Remember, this is many robotic studies largely where Andy Clark is big. Intelligent directed behavior may not be viewed as doing or thinking the same thing over and over again. Porton Van Gelder suggests that child behaviors in acquisition are the products of a mind in motion, constantly changing itself to fit the whole of its experience based on the actions of the body in relation to input from the environment. So this is not to get into a lot of bigger issues, but this is very consistent with epigenetic approaches to acquisition of complexity that are very prominent right now. So I think I'd like to say that I'm finished, and I have a little bit of time for you guys to ask questions, and thank you a lot for listening.